Welcome to all of you. In this session, we are going to understand the Scilab program for DFT calculation without using the inbuilt function. So here let us first go through the detailed calculation procedure and then to the Scilab program.
Now the DFT is defined as same formula once again. X of k is equal to summation n is equal to 0 to n minus 1 x of n omega n nk for all the values of k ranging from 0 to n minus 1. Now let us define all these variables inside this. So here overall agenda is we are converting a time domain signal to the frequency domain. So that is x of n is a time domain signal. We are applying the concept of DFT for that, and then we are converting this time domain signal to the frequency domain signal. Now defining each of these over here. X is the input sequence in the time domain, so that's what I told, conversion of time domain we are making. So that's why x of n is the input, so x is the input sequence in time domain. Capital letter X is the output sequence in frequency domain. That is, frequency domain we call them as coefficients. The values in the frequency domain we call them as coefficients. So one thing you have to observe over here, if the time domain sequence is being represented in the small letter, the corresponding transform domain signal we are going to represent in the capital letter X. So you must make a clear differentiation between these two. In case of DFT, if you are calculating, then always remember that anything represented in the small letter x that represents the signal in the time domain. If it is represented in capital letter X, then it is going to indicate the transform domain coefficients. So while making the representation in the write-up, one must be very clear about the making use of the small letters as well as the capital letter. Now continuation, capital letter N is the length of the sequence. So overall length of the sequence with respect to the previous PPT, there were 4 values present. Therefore, if we define the length of that, then the length n will become equal to 4 for that particular case. So overall length of the given sequence is defined by n, and also at this instant you have to remember that length of the input sequence and the length of the output sequence are going to be the same in the DFT. N and K, small letter n and small letter k, sequence number of time domain and the frequency domain respectively. So this is the time domain signal. So summation is running with respect to n, small letter n. Therefore this small letter n is defined with respect to small letter x. So this is a time domain. Therefore the small letter n is going to represent the sequence number with respect to time domain. Similarly, K is going to represent the frequency domain part. Therefore, K is a sequence number with respect to the frequency domain. Omega n is the twiddle factor. We can call this as omega n, or in some of the contexts it is also referred as Wn. In either way representation or pronunciation, it is going to be the same, that is the twiddle factor. So twiddle factor is in this part. So this twiddle factor is the complex part of the DFT, and it is represented by omega n nk. The complete representation of this is being given over here. So omega n nk, it will be given in terms of exponential, that is e to the power of minus j 2 pi nk divided by n. So j is the complex factor. Again, this is further represented as cos 2 pi nk divided by n minus j sin 2 pi nk divided by n. Within this representation, 2 pi is a constant, n and k are the sequence number that will be known when a problem is being solved. Capital letter N is the length of the sequence, so that will also be known while calculating when the values are being given in a problem. So that means overall we will be aware of all the variable values present over here. So by substituting that, we can calculate. The term j is going to be the complex factor. Now let us get into the calculation of DFT of a given sequence. Let us go through the problem statement. Find the DFT of a sequence x of n is equal to 1, 1, 0, 0. Remember, we are applying DFT only on discrete, periodic, finite length sequence. So these are discrete values, these are periodic in nature and also finite length. That means length is equal to 4 limited. Therefore, this is a finite length sequence. So let us go through the problem identification in a proper manner. So I told you in the previous slide itself, we need the values of twiddle factor. Therefore, throughout the calculation of DFT, I have put this at the side. So remember, so these values you will keep identifying as you keep solving the problems. At every DFT calculation, we need not to show the calculation for this twiddle factor. You can just remember it and make the substitution while calculating the DFT. Now let us go through what are all the given parameters and try to understand the problem in a proper manner. Length of the given sequence n is equal to 4. So how to identify this length of the sequence? Just count the values. The total there are 4 values given. Therefore sequence length is equal to 4. So that means capital letter N will be equal to 4. Right? Then how many time domain values are being given? Equal number of frequency domain values we are going to get. Therefore, for k, that is the frequency domain sequence number, runs from 0 to 3, that is 0, 1, 2, 3. So this can be identified from this representation. Right? K takes the value from 0 to n minus 1, n is the 4. So k takes the values from 0 to 3, that is 0, 1, 2 and 3. So one part is over. Then let us identify this x of n in a proper manner. 4 values are being given. How to identify these 4 values with respect to its location? Right? So this point is location 0, this point is location 1, location 2, location 3. That is x of 0. I am just x of n is being given. I am substituting the value 0, 1, 2, 3 for this small letter n. X of 0 will become 1. So that's the first value we are going to have. X of 1 will be 1. So that's the next value we are going to have. Then x of 2 is 0. X of 3 is 0. What it means? Once again, more explanation about this. In this diagram, you can observe that x-axis is the sequence number, that's the n value. The same n value I am representing over here. Right? So 4 values are there. Therefore, it takes the value 0, 1, 2, 3. At location 0, the amplitude of the signal is equal to 1. That is what we mean for x of 0 is equal to 1. So the value at location 0 is equal to 1. Then at location 1, again the value is equal to 1. That is what it means for at location 1, its amplitude value is equal to 1. Then at location 2, its amplitude value is 0. At location 3, amplitude value is 0. That is being represented here. At location 2, amplitude is 0. At location 3, amplitude is equal to 0. So this is what the basic understanding of a very simple DFT problem that you have to make. See, without understanding this, it will be quite difficult to make the solution of it. So what is being given as a data, we must know what it is actually. These are not simple numbers. These are the amplitude values of the signal at those particular locations, location 0, 1, 2, 3. This always starts from the location 0, right? Location 0, remember that. So always starts from the location 0, continues sequentially location 0, location 1, location 2, location 3. So that's why we are not going to mention the locations while giving the problem. Its amplitude values are being represented over here. In any of the problem, if it is something like this, find the DFT of a sequence so and so, then all these values are going to represent the amplitude of the signal in time domain. Remember, this is the value in the time domain, and we need to convert this to the frequency domain. To convert that into the frequency domain, this is the formula we are going to have. So x of k is equal to summation n is equal to 0 to n minus 1 x of n omega n nk for all the values of k running from 0 to n minus 1. Now let us go through the calculation part. Okay, so we need to calculate this at each values of k. So at k is equal to 0 we are going to have. So why we need to take k, why not n? In the sense, with respect to the left hand side parameter we are going to make the calculation. So that is frequency domain 0th coefficient we are calculating. Therefore with respect to k we are going to take the sequence number while calculating. So at k is equal to 0, x of k will be, you can also write it as x of 0 is equal to, because k is equal to 0, I can substitute the value of k over here and I can call it as x of 0 is equal to, substituting the values, summation n is equal to 0 to 3, that was n minus 1 representation, sequence length n is equal to 4, so 4 minus 1 it is 3, so total n will take 0 to 3, x of n omega 4 nk we are going to have. This capital letter n value has been substituted. Now we are going to expand this summation to discretize in the discrete manner. Now expand it at n is equal to 0. This is what the first part we are going to have. So small letter n is equal to 0. This will become x of 0 written over here. Twiddle factor, this 4 will remain throughout the calculation as it is. We need not to worry about that. Small letter n, at the first time it will be equal to 0. Therefore omega 4 0 we are going to have. With respect to k is equal to 0 we are calculating, that k is equal to 0 is being substituted over here. Second part, so k will remain 0 throughout this calculation. So that is not going to change with respect to this particular calculation. This particular at k is equal to 0. Therefore at in the next point n is going to increment by 1. Therefore x of 1 omega 4 n is now equal to 1. K still remains the 0. Similarly x of 2 omega 4 power 2 into 0, x of 3 omega 4 3 into 0 we are going to have. We are going to make a substitution to all of this. X of 0 is known, that is given in the question itself, that is equal to 1. This will become omega 4 to the power of 0. Anything raised to the power of 0 will be equal to 1. So that is being substituted. Then x of 1, that is given in the question itself, that is also equal to 1. Omega 4 power 0 it will become, so that is once again 1. Then x of 2 is also given in the question itself, that is equal to 0. So 0 into 1, twiddle factor to the power 0 it is going to happen, therefore it is equal to 1. Similarly x of 3 is given 0, twiddle factor will be equal to 1, because once again twiddle factor power will become 0 over here. 3 into 0 is 0, so that is once again total value will become equal to 1. Now this one as well as this one will be equal to 0. This will be 1 plus 1 we are going to have. So final value we are going to 2 after the simplification of this representation. Similarly, we are going to calculate at k is equal to 1. That means throughout this calculation k value remains as 1. capital letter N, that will remains as 4 throughout the complete calculation. So representation summation n is equal to 0 to 3, summation range will also remain constant throughout the calculation. X of n omega 4 nk, expanding that x of 0 omega 4, first time n value is equal to 0, so this is n value 0 into 1, 1 is the k value. Then x of 1 omega 4, n value is equal to 1, k value is equal to 1. X of 2 omega 4, n value is equal to 2, k value is equal to 1. X of 3 omega 4, n value is equal to 3, k value is equal to 1. Now simplifying all this, this will become omega 4 power 0, omega 4 power 1. After simplification, that means multiplication of these two is what I am saying, simplification. Then this will become omega 4 power 2. This will be omega 4 power 3 we are going to get. For all these twiddle factors, we have calculated the values previously. That's what, remember these values, remember these values. So that's what we are substituting over here. X of 0 is equal to 1. Twiddle factor omega 4 power 0 we are going to get. So that will be equal to 1. X of 1 is equal to 1. That is from the given problem itself. Omega 4 power 1 we are going to have after simplification. Omega 4 power 1 is nothing but minus j value, that minus j substituted over here. Then x of 2 is 0. Omega 4 power 2 value is minus 1 substituted here. Then x of 3 is equal to once again 0 given in the question itself. Omega 4 power 3 is equal to j, that is being substituted here. So these two will become equal to 0. 0 multiplied with anything is equal to 0. So these two will become 0. Then this one, 1 into 1, 1. 1 into minus j we are going to have. So after simplifying this, we are going to get the value 1 minus j as a answer. Let us make continuation of this with respect to k is equal to 2 as well as k is equal to 3. So with respect to k is equal to 2, similar solution we have done. But one thing you have to make an observation over here, that is with respect to the twiddle factor. Just go through the twiddle factor. So since k is equal to 2, this will become 2, and sequence number n it will takes 0, 1, 2 as well as 3. Now if you make a simplification of this one, now take this one as well as this one as an example, as an example. This will be omega 4 power 2 into 2, that means omega 4 power 4 it will become. So while calculating the twiddle factor at the beginning, I told if it goes beyond the range, then it will be once again residing on the same unit circle and its values keep repeating. So that means omega 4 power 4, omega 4 power 4, its value will be equal to omega 4 power 0. So at this location we can substitute the same value that we have calculated for omega 4 to the power of 0. Similarly, you can observe here it is omega 4 to the power of 3 into 2, that is 6. Omega 4 power 6 we are going to have. Now what is that value? So this is for the calculation. Omega 4 power 6 will be equal to omega 4 power 2. So all these four values will keep repeating again and again. So in those places respective values will be substituted. So by making use of this particular substitution, we are going to have the calculation and we are going to get value 0 for this one. Similarly, for k is equal to 3, we are going to get 1 plus j. Remember, here also you need to identify 3 into 2 omega 4 power 6, so that is power present, and here 3 into 3 omega 4 power 9 it is going to have. So for 9 I have not represented over here. You need to make a continuation for this. After omega 4 power 6, then it is 7, then 8 and 9 you are going to have. Then for that we are going to have somewhere over here that omega 4 power 9 will become equal to omega 4 to the power of 1. So that you can just make a continuation and you can identify that value. So by making use of that, we have made this complete calculation. So 4 values are the inputs, 4 values are the outputs. So now we have to make a representation of x of k in a proper row matrix. So final value in the frequency domain, that is x of k, will be equal to 2, 1 minus j, 0, 1 plus j. Remember, locations remain the same. This is the 0th location, first location, second location, and the third location we are going to have.
Now let us go through the Scilab program for it. The sequence that is under consideration is 1100, that we are going to take that to the variable x. Then for how much length of the sequence we need to calculate the DFT, that is specified by the user, that is n is equal to 4 in this case. Then length of the sequence we are going to calculate. So in the several cases it may happen that length given as 4 and need to calculate 8 point DFT. In such a case, this capital letter N will become 8 over here. So in such cases, we need to put zeros at the end of the sequence. That's why we are having both N as well as the L calculation, and then we are going to put the zeros if required at the end of the sequence in this line. Then in this part of the program, we are going to calculate the matrix format of the twiddle factor. So we are performing matrix multiplication method in order to identify the DFT. Therefore, twiddle factor matrix is being calculated in this part of the program, and then after, the twiddle factor matrix is multiplied with the input sequence in order to obtain the DFT of the given sequence. So the sequence will be displayed, and then we need to calculate the magnitude and the phase. So here is the magnitude calculation, and then we are going to calculate the phase of the result, and the same will be plotted over here. So this part of the program is going to give us the magnitude spectrum, as well as this part of the program is going to provide us the phase part of the DFT values. Now let us go through the execution of it. After execution, so here we are going to have the magnitude, that is the first graph is the magnitude, the second one is going to be the phase value. The same we can also observe over here, DFT of the sequences. So 2, 1 minus I, 0, 1 plus I is the DFT sequence, and this is what the magnitude value we are going to have, and this is what the phase value we are going to have. And if you just look at what we are going to have as a part of the matrix of the twiddle factor, which will be stored in the variable x2, then it is going to look like x2. So this is what the twiddle factor matrix that we are going to calculate, and that will be multiplied with the given sequence in order to obtain the DFT sequence. Thanks for joining.